Hello everyone, welcome to my YouTube channel. In this video, we are going to explore New York tax data, and first we will just introduce our data sets and variables, what kind of columns we have. Then after that, we will do data wrangling. Basically, we were going to assess our data sets, then data cleaning. After assessing the data cleaning, assessing the data wrangling section, we will just cleaned our data set based on our findings, right? Then we will start exploratory data analysis. We will do outlier analysis, and each data set its own different story. We will see how it's worked, and also we will check to a correlation analysis. We will create a heat map and just check which values are highly correlated to each other, right? So this is our table of contents in my screen, as you can see. So of course, credential, I'm just reviewing my knowledge. I'm looking to some part of the Advanced Data Analytics Professional Certificate by Google, which is, I didn't watch all the sections, but some data cleaning sections are very explanatory, well structured. If you guys want to take the course, I'm highly recommending it. But I use my own analysis, of course. So these codes are just all created by me. But of course, I checked their methods as well. So, okay, so we know our objectives. Like every business, now we are looking for New York tax data. If you are a data analyst and you start in a company and you have a data, and different company have different objective, but in mainly, if that company is not non-profit organization, your perspective is how can we increase revenue, right? In general, I am talking about, of course, if you are looking for some specific case or some department case or risk management department, you are looking for which customers are risky. And of course, they are not directly, but the related revenue as well. So here, so we have in our, this is the column explanation part. We have ID, of course, trip identification number and vendor ID. And there are two vendors in this data, our data sets, Creative Mobile Technologies and Verifone INC. Probably those are Verizon or something, but we have datetime values and pickup datetime, drop-off datetime. Always, we can always use these datetime values, which is great. Passenger count, and this contains how many passengers each ride has an trip distance, and trip distance is in miles. And of course, we have pickup location ID and drop-off location ID. I'm using data set from the DAT course. Unfortunately, they don't have longitude and latitude. If they do have, of course, we will be able to create some cool visualization using ggplot and plotly, and so we can see the our data set in map, and we can do some visualization, but unfortunately, we don't have those values. And of course, understanding columns is really important. That's why I'm explaining everything in the beginning. And of course, I'm going to share this notebook in my Kaggle account or GitHub account. And I will leave the link below under my YouTube channel. So also there is a rate code ID, the final code in effect at the end of the trip. As far as I understand, each GFK standard rate is standard rate, and GFK is airport rides, Newark, Nassau, Worcester, and they're changing it. I think probably they are giving a different price for each rate code ID. And then also there is a, I don't understand, this flag indicates whether a true record was held in which memory. Okay, so this one is payment type, credit card, cash, no charge, dispute, unknown, and voided trips. We will check all of this one by one, and we have fair amount, extras, and extra surges, and tax year, and improvement surcharge, tip amount. We have tip amount, and automatically populated by the credit card trips, and cash trips are not included. We will be able to find the cash tips, right? We have total amount, we have other amounts, so we can just calculate to cash tips as well. Okay, so we have total amounts and total amounts as well. So basically, they're using some different pricing tips. Of course, we know currently there are different pricing methodologies, right? Like action methods. So right now, we know the Lyft and Uber, they're using surging price. So in that price case, you have limited. You are supplying limited amount, right? You have limited drivers, but demand can be fluctuate, depends on the day, or if it's a rush hour, or if there is some game, or let's say there is a rain, and those times and demands will be increased in their search uh, price case. In this, if there is a demand higher and your price will be increased, then go back to normal, and they're really using this price case successfully, as far as I understand. So we are importing our libraries and pandas, of course, Seaborn and pandas plotting, and of course, I created some helper functions. I showed those before, and it makes everything easier for us. If you're a data analyst or data scientist, you are using some code again and again. So creating those kind of functions make things easier for us. So, and for reusability, you don't have to write the same code again and again. So creating functions always useful. When we start to use them, I'm going to show each code pieces as well and explain them line by line. And this code is just saving the for example, we create an image or a graph by Pandas, Matplotlib, or Seaborn. This code is going to create an image path in our path, so in the current path, and it will also create the image path. And just, okay, this one is from the different project, and let's say, let me change this name. New York taxi, right? Okay, New York taxi. And so this, it will create using this paths library, it will create an image folder and then New York taxi project folder. Then it will just add each file extension with the figure ID to that folder, which is very simple, and it will create a high resolution images for us, and so we can use it. We can even include those visuals in our even Power BI visualization as well, or we can just copy paste in our report, right? So okay, we are just gathering part. We are reading our data set. We have just one data set. In the work case, you have sometimes external, internal data set and different data set. You have to merge data set, and sometimes create a master data set, or just understand each one by one. Then go to use merge data sets. In the assessing part, what we're going to do, we are going to use the checkdf function. What checkdf function does here, I might part charm here, and so I will close. So bring the checkdf. Okay, this is the checkdf function. Okay, this is real small here. Let me bring it to our notebook here. So here, what it does, this checkdf function takes a data frame, and then it will give us a general observation side of the data frame object, right? We have some arguments here, and it has 5 tail, and these are the set it values in the beginning, and detail false. Okay, what it does, it gets the index, what it index shows as the index of the data set, right? And shape of the data set. We will see the type of each columns, right? For example, object or integer or float, right? Or datetime values, or and also head, tail. Of course, you guys know, if you say the data frame that head, it will show us the first 5 value, but you can change that first 5 by entering an argument saying just, I want to see the first 10 value, right? Depends on the hour needed, but we just pick the 5 here, which is the actually the default value. But anyway, so whether is there any duplicated value, it will change the all rows in the data set. If there is an identical column, it will show us whether there is a duplicated value or not, and it will show us that for each column, is there any NA value, and it will also show us, this function will show us the total NA values. And if we say the detail, and it will just shows us the quantiles as well. Okay, so we said So here I just commented out this part. You can see the different quantiles. Usually in this part, in the default, Python shows us the mean, median, and 25 quantile and 75 quantile and the rest, right? And but you can change these values here by using quantile function in the pandas data frame. When I run this one, as we can see, this is index and step is 1, which is a good sign. And this is how many observation we have in our data set. This is how many variables. That means how many columns we have. This is a tabular data, of course, and we have this amount of rows, this amount of variables. And so these are the things. And in this here, when you're assessing data sets, so for example, this is probably is just the index. Just ignore this one. Vendor ID, okay? What we are expecting, it says integer. We are going to check in our data set observation whether it's an integer. So these values are consistent with the real values. Sometimes it says object, but it's an integer. Sometimes it says integer is actually in their nature is their object. For example, we will look at this, but for example, it's gender, right? And for example, 1 for female and 0 for man, male, right? And this is an object, right? Categorical variable. So we can take as a, but our purpose is different here. Okay, vendor ID is 1, 2, 3, and integer, which is consistent. And pickup time and drop-off time, it says object, but what we are expecting, without even looking at the observation, we are expecting what it has to be datetime values, right? But let's see what kind of, okay, we have datetime values, but it says object. So we have to transform this. What I am going to do, I'm going to take my notes. Okay, this value is not consistent, so we have to transform this value to datetime value, which I did here actually, right? And I mentioned here, there is no missing value, I said, but as we can see, let's just check the missing value. Okay, so it shows whether each column has a missing value, and it also shows the total and missing values as well. As we can observe here, there is no missing value. So what I did, I write here, and this datetime values need to convert to the datetime type. Other variables are consistent with the data types. So we can continue to observe those values, right? Okay, also okay, so we are looking at the data set. And also, this is a descriptive statistic of our data set. As we can see, it shows if there's an, of course, it also shows us the count values, right? But if it's categorical value, it also shows us the unique values, right? For example, it says, for example, this one is almost same. Probably there are some rides on the same day, right? That's why it's not exactly the same, but passenger count, which is an integer, we can see, but store, this one was the categorical value, we get this unique value, and frequency as well, right? And if it's just that, these are for the categorical values. And okay, so these are the, of course, frequency. Okay, mean, standard deviation, minimum value, 25% quantile for each values. What can we understand? We can just check whether we're how much the difference between mean and median value, right? And it could tell us and by looking at whether is our data set right skewed or left skewed, right? If we can look at it here, our standard deviation, mean value, and median value. It's a little bit hard to see, but of course, so this is a maximum values. It's really close. This one is not. Okay, as you can see, fair amount is a mean value is $9.50, but here is almost $1,000, right? This is just an outlier, but when we are looking for outliers, after identifying outliers, we can see that, hey, okay, this is an outliers, but is that an error or is just the nature of the data, right? When you think about it, the outliers, for example, if you are looking for income in your area or in Boston, you can see some incomes are really median income is accumulated somewhere, but you can see that some incomes, some households are making much having much more income than the others. This is not an error. This is an outlier, but this is nature of the data. So we will understand, we will by looking at the, for example, tip amount, 200, it is possible somebody just give it 200, and this one is different, and total amount, as I said, is the same because we are just looking at the amount, and this will be affect the other one as well. And then, so we are, as I said, we can just look at this 50 quantile is a median value, right? And we can just compare this median value in the mean value. For example, let's check at the fair amount, $13. Okay, so what is the median value for the fair amount? 9. That means our mean value, $13, is bigger than the median value, right? So that means our data set is right skewed. It's like at this kind of shape, right? From the like this. Okay, so these are the observation. You guys can check one by one and understand the difference. These are giving us some story to understand our data set, always looking at this descriptive statistic. So, okay, so I took the sum rows and we set some variance in data. We actually find out that because the standard deviation here, you guys can check it, and difference between the mean and median values, right? See, high standard deviation, that means we have high variation in the data sets. And also what I realized is this, there are some, and when you look at the minimum values, right, we can see the fair amounts and extras and taxes and total amounts are minus or negative values. And we should examine this. This is not possible, right? Whether this right is canceled and what happens, what we know, and we will look at it. So, but we know there are some disputed riders, right? And there are riders no charge. We will understand them one by one. And this is how we assess your data set. And then you can look at the tidiness. What is the tidiness and whether your data is messy or not. And for example, let's say one column contains 2 different variables. This means that data set is messy. So you have to separate those columns and create their own columns, right? So, so this is our actions. I always write my actions, what I'm going to do. We mentioned already do's, some category count shows a numerical value. We also mentioned that one, and we can change, we can look at the different visualization types. We can pick whatever we want to depend on the data story, right? And so this is a data cleaning process. So I am going to convert this object values to datetime values. It's so easy. We are using pandas to datetime values and giving that variable name and then running it. So what it does now, we change these variables data type to datetime values, which is easy. Then we are looking the info here again to check whether our code is worked or not. Always just the test whatever you did, test whatever you did before continue the rest of your analysis process, right? And then make sure total amount columns accurately sum up the individual charges. Okay, so we have a total amount, right? But we are expecting other values in our data set should be sum up the total amount, right? To understand whether there's an error in our data set or not. This is one of the important things. If you have those kind of values, you need to see, they need to sum up, you should check it. There is a basic method, and these are the software testing method. You can use this set values, right? So I set that, I just made this tolerances to $5 because there are some data types are giving error, and I will, and I realized those are come from the, for example, right now it's, in the beginning, of course, always we just make a tolerance, right? 0. So what happens, what I'm doing here, iter of df.iter, we are creating a for loop and we are going row one by one, each row, right? What we are doing here, row fair amount plus extra plus tax plus tip amount plus tool amount plus and improvement surcharge needs to be equal to total amount. That's what we expect from our data set. But as we can see here, what I am doing after calculating that sum of columns, I am just subtracting the sum of columns from the row total amounts, right? And just checking here, a set is checks whether our condition is meets, but as we can see, and we are getting the absolute value. If it's lower than or equal to tolerance, that means that's okay. If it's not, it will give us a assertion error, like we can see here. The row 5 doesn't sum up correctly within the tolerance. We are getting the index number. So we can just check those rows, right? I check one by one. And for example, let's change the 2. Oh, okay, so for example, let's look at this row, right? And we just look at the row 5. This one is just, let's first look at the row 5. So what is the problem here? Let's check it. So what we're looking for and the total amount, right? So total amount is $12. Where is the cause this problem? It's probably come from the cash tip, right? Because we don't see the cash tip. This will help us to find out how much customers give them a cash tip, right? So this is the way. So the $5, probably there is no cash more than $5. So that's why tolerance 5 is works here without any assertion. Okay. So anyway, so we realize, at least we realize, and there are cash tips, and let me just check the data tab. Is there any columns give us a cash? Okay, this says cash. Okay. Okay, there is in this variable, we can see the payment type, we can see the cash, but we don't see the cash types, right? Anyway, so we did this, and I'm calculating the cash tip here, right? Okay, so basically I'm just from total amount, and I'm calculating the rest, and like we did here, like summing up all of them and just subtracting from the total amount and finding the cash tip, right? And the rest must be the cash tip. So what we did here, this is it. Okay, excuse me. For date type columns, guys, and you can find many things. This is just always plentiful to getting different. This is for the future engineering. If you have a datetime values, you could get many things: days, hours, and months, and years, and month names, different things. And if you can just Google, Python datetime extraction, and you will probably see many websites and just gives you all detailed explanation. Let's just check out this website. So as you can see, it's bringing minutes, seconds, time, whatever you want to. You can find it in the Google by Googling or asking the ChatGPT, right? It's usual, and I would, of course, recommend you to use ChatGPT. It's not going to replace you, but if you can use efficiently, for example, instead of Googling it, hey, I have this datetime value, for example, let's say, and let me show you how to use ChatGPT here. Okay. I have this variable. I need to extract month, week, and day. This is it. So it will just, as you can see, it gives an example and shows us how can we extract them. And if you have pandas, df.datetime, dt.month will give us a month, and each week, right, as week number, as calendar week, and dt day. This is it, guys, and you guys can ask any question and just get the result as fast as you can, right? You need to. It's only helps you. It's also helps you to speed up your data analysis project as well. Okay, just I am running, and it's the same thing. And you don't have to remember. You cannot remember all the syntax. Nobody can. For example, I'm using JavaScript, SQL, Python. and React framework, right? So how can I remember everything? It is impossible for everybody. So each time I'm looking back to my notes or sometimes Googling it, right? So now I'm just checking whether I have those columns. As you can see, I have month and day columns, right? I have cache type columns. Okay, so this is it. And so how can we derive trip duration, right? We have pickup date time and drop off date time, right? How can we do that? We can just basically subtract them, right? But here, what I am doing, let me show you. But you are now, if you subtract both date time, it will subtract the date time from each other, and you will see, for example, weird things like 0 days and something like that. Okay, 0 days, and that means that's 14 minutes. So what could be useful for us, just getting out the minutes, right? How can we do that? This is the way. Df we created by subtracting says and assign this value as a new variable. We just create a new variable called trip duration, and then we just change this trip duration, date time, total seconds. We will get the total seconds, and just divided them this 60, right? If we divide this then 60, we will get the total minutes. So as you can see, we will get the our trip duration and how many minutes it is. Okay. Okay, this is it. I hope you guys understand my logic here. Okay, so we start to exploratory data analysis. Okay, so there is another user-defined functions and created by me. What this functions does, and it's just the text data frame, and you can just set a threshold for the categorical and cardinal values, and it will return you categorical, numerical columns, and also categorical but cardinal columns. What does that mean, categorical but cardinal? That means their categorical value, right? For example, but they are repeating many times, and taking them as a categorical value is nonsense. And because if they're repeating more than 100 times, it's just really hard to work with that data set as a categorical variable. Okay. So let me show you this function as well. Actually, it's just it's probably here. Okay. Live threshold. Just real quick. Okay, grab call me. Okay, let me just get to this part. So it's basically what it does is just that we are giving. Okay, let me get the top part too. So it will be because this way is this function seems okay. So what it does, it takes the data frame. What we are doing, this is a list comprehension, guys. Call in data frame columns. We are getting our data frame columns one by one, then looping through. If this is this is a list comprehension. What it does is basically a for loop, and if data frame that column data frame and that particular column in that for loop, if data type is object, we are saying categorical columns. Numerical but categorical columns, what we are doing, it is an object here, same thing, and number of the unique values is less than. So this time is we are saying that date type is not object. That means not object. That means if it's an integer or something else, and number of unique values is less than our categorical threshold. We are saying that, like I said in the gender, right? For female 1 and male in 0, this is the categorical value, but it seems as an integer. They just put it as an integer, right? So what it does here, just look at it in that this gender example, categorical threshold is 10. What is our different genders in this case? Of course, I'm not saying that there's other non-binary genders as well. I'm not talking about that, but in this case, we have two genders, right? What we are doing is if they're less than that threshold, 3, 4, whatever it is, if it's less than 10, that means this is a numerical values, but actually they are categorical. Then we will include this. This is how the things works. You guys can just check it one by one, okay, at the end, but it also returns those values. Let's run this function. Okay, we got to categorical columns, store and select makes sense, month, day makes sense, right? And vendor ID makes sense, passenger count definitely makes sense. passenger counts 1, 2, 3, 4. Okay, these are integer values, but they are actually categorical values. This is how our function got it, because their number of unique values less than 10, right? Probably we have no more than 10 different customer in each trip. Then payment type makes sense, extra, tax, improvements. Okay, these are not make sense because we know these are numerical values, but probably these are recurring in the data set less than 10 times. For example, there's not much extra charge or MT tax. That means that's why our function think that those are categorical columns, but we will change that. So, okay, I took a columns here, right? Okay, so then numerical columns, duration times. Okay, these are not numerical columns. Fair amount. Okay, maybe we can just add our function. If it's a date time, don't add to numerical columns, right? This is how you can improve your functions all the time. Fair amount. These location IDs, they're not numerical, right? These are just an ID. Okay, so we know our data set. We understand it, right? Then when we move columns, these are needs to move numerical columns, as I mentioned before. Then what I'm saying, this is just a list method, extend numerical columns with the new move columns. It tends to remove, I don't want to see this, date times, right? And week, pickup hours, right? Months, drop off date, drop off hours, right? Okay. So this is it. Then I can. And so what I'm saying here, then I'm moving those ones into the cat columns as well, category columns as well, right? Okay. Okay, so there is no categorical but cardinal values. I explained what are those. And so analyzing the categorical values. So there is a categorical summary function. And let me real quick show you that one too. Data preparation. Not this one. The cat summary function. Basically, here, let me get this function in the our notebook. So guys, instead of writing, it's just this code. Whenever how can you just look at the categorical columns first? Of course, value count and the box plot, right? It's just to give you the first and just most clear answer first. Then what can I do is what this function does is just get the data frame and the column name. If it's there is a plot values default false and figure size, you can change this one, depends on your data set. But here, what it does is data frame, we are creating a new data frame, but what we are getting, get to that column and count the values, right? You guys already know the value counts, and then data frame value counts, and we also just dividing the len data frame, find the ratio of that value in the data set. Okay, as we can see here, for example, start and forward flag ratio. This one is another good example. I actually didn't understand, but for example, 4 months, how many times they repeated. This is the value. This has come from the value counts. This comes from the ratio calculation here. And this also just creates a count plot, right? So we are seeing what we are seeing here, right? We are seeing that means if they're counting more, that means there are more trips in this month. So for example, there are more trips in October. There are more trips in May, right? This is how we can observe our values. This gives us some idea. There are less trips in July. There are less trips in the summer months. These are always we can just understand from this data on this visualization. Also, this one is the weekdays and ratios, as you can see here, okay? So how many times? If we can look at the visuals here, and for example, Sunday, less right, Monday, less right, but other days seems more consistent comparing Sunday and Monday, right? So this is another way how to vendor ID. Okay, first vendor ID, second vendor ID. As we can see, second one is higher, right? What one probably that one is Verizon, right? And then rate code ID. What was the rate code ID? Let's remind ourselves. Okay, this one is the, okay, we are just whether it's the standard rate or not. Let's go back to there. Okay, so we did here, we just checked the red coin ID. Basically, most of the rights consist of their actual standard rate, right? As we can see here, other ones, and there is a 99. This is probably is a data entry error, right? Because there's no red code ID, it's 99. Or we can ask the data owner, right? In this situation, if you're in the company, what you can do first, you can ask the business department if they don't know the answer. If you think it's a more technical problem, you can ask the IT department as a data analyst. This is how you can work. Okay, so there's a payment type, and as we can see, most of the payment types is one must be a credit card, and we can check to our data set, and let's just check it real quick. And right, where are the payment types? Okay, a credit card, second is cash, no charge and dispute, 3, 4, right? Let's go there. Okay, yes. Oh, there is a no charge and there are disputes, right? And small amount, but mostly paid by credit cards, 67% of percentage. And there are others, some really good amount of people paid cash as well, right? So these are the others. I took the same notes what I talk about. Of course, you guys can read later on, right? So now let's analyze the numerical columns. These are our numerical columns. This is the numerical summary function. What this function does is just describes, give us the for each column in the, using the describe function, give us the statistical observation for each values. Let me show you real quick. Okay, this is the num summary function. Okay, let me just show you real quick here. Okay, guys, so what it does, takes a data frame, a numerical column, and if it's there's a default plot value, plot type histogram, you can change plot type to box plot as well, right? And if you say plot true, and you can, if this is a default value, of course, you can pick a box plot too. And as you guys know, box plot can shows us the outliers values as well, right? Then what it does is just to describe the column. We know this function is just gives us the descriptive statistic of that example actually. And also, is there an NA value? Then, of course, the visualization of that observation, okay, a variable actually. So trip distance we mentioned here, as you can see, mean value, median value. Mean value is bigger than the median value here. What we are expecting similar to this. This is a rice cube data, right? Right. I'm a little bit confused. Just right. Yes, I want to show you how can you just see the understand the right skew. What does that mean, right skewed data and left skewed data? This is a right skewed distribution, and if it's otherwise, let me just show you. And this is then the left skewed data. Okay, so I wanted to show you if you guys don't know about it. Okay. So this means what we can see here, most of our rides is trip distance is see 74, 75, even until the 75 quintile, they're less than almost 3.5 mile, right? And most median ride distance is 1.6 miles, okay? So this gives us some understanding. Most rides are shorter trips, unlike the longer trips, which is understandable in the New York, right? And this is pickup location ID, okay. Okay, this is a different story, but what we can observe here, guys, and the pickup location ID, right? If it's just what it does, this box plot always just shows us how many times this value is repeated, right? This can show us which places has more traffic. For example, this is the probably it's just where is the traffic is just more busy around here, right? Because we are picking a lot of people here and here and here, right here. Probably we will see same pattern in the drop-off location, right? Yes. So same thing we are observing. That means there's a probably, Long Island area or Manhattan, and we are observing we are observing very busy traffic. You can just exactly say that if you are understanding the data set, right? It's a business case as a fair amount, right? Of course, looking at the descriptive statistic does not make sense here, right? Because it's not an actual numerical value, but of course, fair amount and count, okay? And mean value, standard deviation, there is a standard deviation, which is 13. And that means there's a variance. And after the mean value, as you can, 75 percentile is not really far away from the mean value, right? And also the mean value is a little bit close to this because of the standard deviation. Otherwise, as you can see, this is our median value, right? And that means that mean value is again the median value. This one is a right skewed data as well. So as we can see here, so these are the standard visualization. Of course, you can just make this axis much more sense. For example, this function uses 0, 200, 400. You can make these ticks are smaller, right? And you can see much more detailed version of this. But we are understanding from this data set. And also there is a minus value, as we can say, we have to check it. This one is as well. And it's I don't understand this. Maybe it might possible if somebody was going from New York to Boston or DC, right? Or somewhere else. Okay, tip amount. There is no people. There are some people, 25% of them not giving a tip, and median value is $1.35, and this one is here, and mean values are really close to each other. That means there is not high variation, but also there is an outliers, which is possible. Of course, we have to check it again. Okay, this one is here. And also tools amount, as I said, is not important because it's not repeating a lot. And total amount, okay, let's look at the total amount. Same like we observe in the fair, right? And it's a 16 and standard deviation, as we can see here. And that's why there is a difference between mean and median values. And the median values here, 75% here. That means most of the ride is under the $20, right? This amount is really huge, right? Okay, so this is what we understand from our data set. And there are cache tips we created, and there is a mean value. Of course, probably it's this, these mean values come from probably the same rows, right? We can say that. And what we can say that, and I think the cache tips are mean values $5. Sorry, median values. If somebody is paying cash, that means they're paying more tip. It's actually just a little bit reverse in psychology. I think if I'm paying cash, that means just people easily, just using the credit card. You are just saying, just slipping the card and just payment is handled, right? But paying cash, you actually see and feel how much you are paying. But as you can see, it's just that means we can just infer that, okay, that means if people paying cash, that if we have enough data, of course, you can do A/B testing or, right here and just compare the whether it's just, we can just create a hypothesis. We can say that paid by the credit card tip amount is equal to cash tip, right? This will be, our null hypothesis, and then we can calculate. Basically, we can just use bootstrapping and just compare those differences, right? Each time we can just get some observation, then calculate the distance. If there's if we can then look at the p-value and understand whether there is a difference. Right now, my observation is this, but we can just prove that statistically. Maybe I didn't do that. Maybe we can do it in the next video, right? Okay, so this is the part. Iteration limits, right? Okay, so mean 17 minutes, right? And what was the mean distance? Let's just check the distance. Oh, this is the duration, and we can just calculate, just compare this one as the distance, right? That will really make sense. but in New York traffic, okay, so standard deviation is really high. Why is that? It's probably in New York traffic. That was my assumption, because as you can see, this is a mean value, and there is this is the median value. Again, we are seeing the right skew data. In real data sets, you usually see the right skew data sets. And this is, yes, and there are some max values. Okay, this one is seem a little bit weird, but let's just calculate this, right? And let's divide it to this one. This one is minute, and just how many hours I want to see. Okay. Okay, this is this is weird. This means, for example, this is just a simple inference. What we do is just that we have minutes, right? And we just divide it to 60, which means 1 hour is a 60 minutes, right? And I just divided. That means there are writes is 23 hours. That might be that might be not true. This I don't think this is true, but we will of course examine this one later on too. We set 2 minutes. So forth. We are getting the same observation from the other ones, right? I hope you guys understand how you can look at these descriptive statistics. Okay, there is an improvement search age. I don't think it's there really successful. As I mentioned before, some companies really like Uber, Lyft use this one is really successful. And we also mentioned all this. I also mentioned we don't need to read this again. Okay, so how many refunds are there? Because we want to see there are some values are less than 0, right? I'm guessing these ones are refunds. And when we run this, we are seeing this is how we can just do the compare this. We are getting our data frame, and inside our data frame, whatever those values, total amount is less than 0, this condition, and we are getting 14. We are getting the len of this data frame. Otherwise, it will show us the each observation here, 14 observation. Okay, then what we can do here, okay, so let's get the just from this values, payment type, and the duration minutes. Why I am doing this is because, first of all, how people pay this trip, right? And also, is there actually a trip here, right? Just if I can see, for example, trip duration minutes, maybe it's just that if there is less than 1 or 2 minutes, that means this people is just entered the right, or rider or driver extend the started right? And it's actually there's a yeah. And then they said, okay, this actually didn't happen. That's why I'm just trying to look at the trip duration minutes and understand what's the problem. Here, after doing that, payment type is, what's that? We observe that this one is, okay, this one is dispute. Other one is no charge. Okay, this one is no charge. 3 is no charge. 4 is dispute. That means, as we can see, these are disputed and a no charge. What happened? 48 seconds. This rise didn't even happen at all. 1 minute. This one is maybe a data mistake. So we were going to ask this. We have to just check this one individually. 3 minutes. Okay, this one is a dispute. That's why disputes are seems a little bit, longer. But as you can see, no charge means this rights actually didn't happen. That's why we are seeing those minus total amount values. And disputes needs to be, of course, there might be a report. There's customer would report that's right, and also driver as well, so we can understand what happened. But as we can see, we can just say that with the trees, this rights actually didn't happen. Okay. Okay, so as we can see, okay, we are in, okay, half and half. This is interesting. There are 7 dispute right. There are 7 disputed right, and there are 7 no payment rights. Okay, so we examine those values. Let's do outlier analysis. I took my notes and okay, so outlier threshold function. What it does function does okay. Takes the data frame, a column, and these are our quantile. If you guys don't know the interquantile method, basically we are getting the 75 third quantile. That means 0.75 quantile. Then we are subtracting that. Then yes, we are getting that quartile. and adding 1.5 and just multiplying with the quantile range. What is that quantile range? We can pick it. But in general, people use 75 and 25 quantiles here. What it does, gets data frame, get that numerical value, right, variable, and get the first quantile. What's the difference? 25. I can put here 20% or 1% to 99%. This depends on my case. For example, if I want to suppress for my machine learning algorithms, some machine learning algorithms really sensitive to these quantiles. For example, linear regression, right? So in this case, we might, and also KNNs as well, I think. So in this case, we can just change these quantile values as well, okay? So here, what I am doing is getting the 25 and 75 quantiles and just subtracting from each other. It will give me a interquantile range. So this is the one of the statistical methods. How can you calculate your outliers, and really common. Also, you can use visualization tools like scatter plot or box plot, right? So, an upper limit interquantile tree, right? This one 75%, 75%, and then adding this, adding interquantile range multiplied by 1.5. And for the same thing for low limit, but this time is just, we are, of course, again, multiplying interquantile range with 1.5, then we subtracting from the quantile one, we are getting our lower limit, and this function returns a up and low limit. So what can we do with the up and low limit? If there is a value is less than the lower limit and higher than the upper limit, we can say that those values are outliers. As I said, this is a general method. In your business case, you can change those quantile values, whatever you want to. And we have check outlier functions we are giving again, and we are running this function here, outlier thresholds here, right? This is an outlier threshold and getting those values. And this one is checking if there's a data type problem. And so if there's data type is not numerical, it's just skip that value, right? So we are getting our low and up limit, and we are checking in the data frame call name if it has a value from the upper limit, right? Upper limit, or if it has a value less than the low limit and return true. It will return as a true. That means it has outlier, right? Okay, so what I'm doing, looping through using the for loop in the numerical columns and getting and creating an empty outliers list. And if it's result from the check outliers here is true, and I'm appending that value to my outlier list here. And let's run it and let's see it. And that means these values are outliers. As we mentioned before, not tip amount, this tool amount and this extra empty text improvement search age, these values are actually, instead of, we can say that these are less repeated values. That's why we are seeing in the outliers. They're actually not outliers. They don't have other values. For example, they're mostly because there's not many text values or extra values, right? 0, 0, 0, 0, there is one value. Even if it's a 1, that means, even if it's just a 5 or 10, that means it's for shown as an outlier, right? That's just the reason I'm explaining here. So best thing is to just subtracting from our analysis, but let's see what the best way to observe this one is the box plot. We already found them and we can just see them, right? And for example, and just let me give you a real quick example. This box plot is just this part on the left part. Let me just find a little bit big one. This part on the left one is the 25 quantile. This one is our median value, 75 quantile. It's just this is the end. So here, this one doesn't seem. So here, all these ones are our outliers. Trip distance has fair amount, as you can see. there is a minus value. There are other quantiles. There is a really big outliers here. And a tip amount, there is an outlier $200, right? And tools amount, as I mentioned, their early values mostly zero. That's why we are seeing all of them as a quantile, because when we calculated them, their mean value is really close to zero. That's why total amount, it has also outliers as well. We actually find outliers. This is how can you find it by visualizing and just looking at these circles here, okay? And this is how can you do it. I wanted to show you how can you find outliers by visualizing your data set. For example, this is really much more visible. I'm doing all of them, but depends on your data set. You need to change these parts, right? And it just takes and just give you more clear results or bigger visuals, okay? Okay, so let me just visualize. I want to show you how can you guys use pair plot. It's just a pair plot shows you the pair for each plot, and also as a scatter plot, and you will see it in a second. It will take some time because it will just visualize a few different columns, right? So what it does is the CNC is a Seaborn abbreviation, and CNC pair plot takes the data frame. Variables are the columns for visuals, right? I just exclude a few of them, as I mentioned the reason before, right? As you can see here, for example, this is the trip amount. If it's just looking at this diagonal values are actually is just instead of the scatter plot, they are actually box plot, actually histogram. So these are really small, you can see, but what you can see from this data set, first of all, you can see correlation between something. For example, let's just fair amount has really high correlation with this on the low level total amount, which makes sense, right? Let's say total amount probably is a fair amount. Let's find another one. There's a little correlation tip amount and total amount too, for example, here, right? Yes. So this how you can send, as you can see, there are some here outside the data set. There are some here as well. Here as well, there are some outliers in our data set. This is another way you can observe those outliers. So I made some comments here, right? And you guys can just, I explained the interquantile range because first we need to understand. Okay, I said, after finding this, so before moving to investigate the cause, right? And I already mentioned that if are they genuine or error, right? If they are errors, we can fix those or remove those. Or if they are genuine data set, as I explained before, the household income, so we should do some other approach. And what we can do, what outlier do our data set is they're affecting our descriptive statistic. For example, as I give an example, they always give an example. For example, there is 5 people in the cafe, right? And in that cafe, if people who are just regular, who has regular job, and if we look at their income, let's say it's just a 50,000 a year, right? But if Jeff Bezos or some rich man came to them, that mean value will increase because there's an outliers who has maybe or a few $1 million income, right? Is that to result in those case, you will just, of course, check the mean value, but what I am saying here, outliers will affect some of the descriptive statistics we are observing. So that's why knowing them, understanding them is really important. And deciding an approach, I gave it here removal. As I said, if it's an error, you can remove it. And of course, it's just, however, be cautious as removing wallet data points can affect your analysis, right? Suppression, this technique replace the extreme values with the closer values in the main data cluster. What we can do, for example, we can say that if they are, for example, we just interquantile upper and lower limit, right? If data observations are higher than the upper limit or lower than the upper limit, what we can do, we can suppress those values for the upper limit and the lower limit, right? And this one is they're not going to affect our data set as much as they do before. But why we can do this? We can do this for some machine learning algorithms. Why? Because some, I write those in the below, tree models are robust, those outliers. Why? Because tree models are just splitting and just branching going down, right? So it doesn't matter the value. But k-neighbors and linear regressions, these models are really sensitive to and significantly impacted by these outliers, okay? Just understanding the model. So transformation, as I said, and of course, for example, if your data is really logarithm, sometimes using the, instead of logarithm, sometimes you can use the exponential values. Transforming those values will help you to make your data more bell-shaped. Bell-shaped means it's just, I'm trying to say, it's just normally distributed. So it's easier to understand those algorithms, right? If you're creating an algorithm, if you are not going to build a machine learning algorithm, you can just report this. For example, if you're creating an executive report or a report to your manager, you can just mention that there are these values and these are that's why our mean value is more higher than the median value, and so on and so forth. And let's continue the highly correlated values. This is going to create a heat map, and you can observe here which values are highly correlated. If they have, and this is our place, if they have positive correlation, that means blue, and if they have negative correlation, that means red. What is the correlation from negative value to positive value? If they are close to, they're between -1 to plus +1, if they're getting closer to higher than the 0.5 from -0.5 minus positive 0.5, if they're getting closer to those minus and +1, that means there is a really high correlation. And when they closer to those 0.5 values, that means mild correlation. If they're getting close to 0, that means there is no correlation at all. For example, let's see, okay, let's see, just let me show you this one. Fair amount, known 0.99 correlation with probably total amount, right? Yes. So what is this important? Because it is important if you are using the linear regression model. I explained here, there is a problem. It's just highly correlated variables can lead to multicollinearity. What is the multicollinearity? This makes it difficult to interpret the coefficients of the model. Why is that? Because it is unclear which values actually affect our quantity, right? For example, in this case, we are, let me give you a different example, actually. You are just, you have stocks and you have stores, you are forecasting the how much each your stores, for example, in your working is headquarters, and you are just guessing which store consuming how much, let's say, water, right, or something else, or pack of salt, right? And to make if there is a high correlated values, and after you get your coefficient or observation from your linear regression, you will not know. It will be hard to understand which one is actually affecting that value, quantity forecasting value, right? That's why this is the problem, multicollinearity. This is what it is. Also, it's just the correlated features can sometimes lead to overfitting. This is another observation. And as we can see, we can find those correlated values using heat map. And for example, my function also here give us the highly correlated values, total amount, the cache by tips. It's calculating, getting the absolute values, not just the looking at the getting the each correlation and getting the absolute values, and whichever each one is higher than the correlation threshold. Correlation threshold here is 0.8. Depends on your case, you can change that value as well in the future. Okay, I hope this part is really understand. And also dealing with the correlated values, I took to just identify, after identifying the correlation, right? And first of all, is important is the domain knowledge, consider meaning of the variables. If one can be considered redundant, the less important removing it might be just justified based on the domain language, right? Dimensionality reduction, there are some algorithms like PCA. You can create a new set of the features and capture the values of the original data while reducing the redundancy, and also some regularization techniques like L2 and L1. You can just penalize your model and having high coefficients, reducing the impact of the correlated features. These are the other ways, and I usually prefer regularization, but as I said, PCA is really important. I usually use PCA for visualization, but depends on your case. Okay, so I'm going to add this new column, our pick column. What I'm going to get is just basically, as I mentioned, using the datetime functions, I will get to dt.hour, right? And it will give me the which hour I picked my customer. So here, sorry, I didn't mean to show you this. Looks like it gives you the which hours you pick from midnight to 23, right here. Okay, so I hope you guys understand this one. So, okay, so I will make a visualization. Let me show you what I'm doing here. Pivot data. Okay, so I'm grouping this data, okay. DF group by hours to pick and day. What I'm taking here, first getting the which hours I picked and which day, right? What it does give me those hours, 1, 2, 3, 4, then each day in it. And then what I'm getting each size, this size function, let me just show you the documentation here real quick because I opened it for explanation in the pandas. Always look at the documentation to understand how your code works, okay? Because it's just a really good way. Returns an int representing the number of elements in this object. So there is an example here. So what it does is just it shows the size. For example, if you say the 4, but for example, it shows 4 here. But if you say column 1, it will show me the at different values. Let me just give you this. I'm sure you guys understand, but I like to explain everything because that's how I learn too. Let's say don't if this is, let's say the F1, and let me just add some repetitive values like, right, 333. But to make a data frame, it has to be equal, I think. Okay, the F1. The F1 that size. Oh, sorry. So what we're gonna do, we will group by this df1 to understand, right? By what? By column 1, right? Okay, let's get it. Okay. So what we get here, and we get 1, 1 for 1, 1 for 2, and 3 for 3 because we have 3 of them. This is the hours list. What we're doing here, we are getting the hours picked and day. For example, for that day, Monday, and that hour, and it just calculates as that's data, okay? Okay, let me just remove this example here. As you can see here, so then what we are doing, and we are resetting the index and saying the name of the count, right? Let me show you that part too. You will clearly understand. Okay, see, this is our pick. This is Friday. This is Monday. This is Monday. Then for 23, right? Just counting for each of them by grouping by each hour. 0 hour, Monday, count them. Get the size, counting it, as I showed before. Okay, so we are going to make a visualization. This is so PLT figure. This one is give you a figure size. You can just change this one is a 12 to 7 and create a line plot. Data is, this is our data, this one. And for x-axis, put our pick, and y-axis, put the count. and for who get the day. So what we will say, these are the giving the name of the labels and titles, right? So, and also grade true, and also we are adding the legend, right? Okay, so what we are showing here for each days, Friday, Monday, Saturday, Sunday, Thursday, and Tuesday, Wednesday, what we are seeing here are the pickup count by weekday, right? And count how many people they picked on those hours, right? So from 0 to 23, what we are observing here, these are days, each different color represents day here, right? So let's just check it here. Let me just make it a little bit smaller so you guys can see it better. So what we are seeing here, okay, from 0 to from 12 a.m. after 12 a.m. probably around 3 to 5 a.m. less than 50 people picked up. But after 5 a.m. to 10 a.m., when we close to 5 a.m., except these two red and yellow, right, lines, they're really high. That means weekdays, right? Those ones are weekdays. That's yellow and reds here. So yeah, sorry, green and red is the Sunday. That means there's not much ride, which makes sense, right? In the rush hours in the weekdays, and that will be more rides between 8 to 10, right? 7 to 10 probably. It's increasing, but in the weekend it's not. But what is the difference? And then, as you can see, we can observe that. And also 15 to 20. There are more rides. Also, we can say also Sundays people are probably not just going out as well. But what we can see here, the midnights, usually in the weekends, midnight Sunday and the Saturday, as you can see here, there is a high demand for a taxi, right? So this is really makes sense. This is how we understand. So what company's purpose? Making more money. So you have a taxi company. What would you do, right? And so you have limited people who are driving, right? Search pricing, that's what I'm trying to understand. So you are a data analysis, you want your companies increase their money. What would you recommend the company? You would say that, hey, why don't we have the data, it seems midnight times in the weekends, Saturday, Sunday, and rush hours from Monday to Friday, there is a high demand. We can, for example, increase our prices because our demand is fluctuating. For example, we can add a search price here, right? Because demand highs, limited drivers, and high demand. So, and you can increase your prices. And other hours, looking at this data regularly and understand whether this search pricing increasing your revenue also, of course, not just the total sales or revenue, of course, to increasing your margin as well. Okay, this is another approach. You're a data analysis, you want to increase your company's and earning money, right? Okay, this is another thing. Let's continue here. So we are creating a 2D matrix here. Just I want to show you this one too. Okay, let me run it first and understand. And it's same thing, and I want to show you with the heat map. Of course, here you guys can see, different parts. And if there's a high demand, for example, Tuesday, and in this hour, around 18, there's a really high demand, seems. And you can say that, you can use a different pricing strategy. It shows the same thing with this one. I want to show you how can you do it in the heat map as well. I'm creating a pivot table, and pivot table after you get in the data, and you can just pick your index and columns, right, and values, and just add it like you are doing in the Excel, right? And I'm adding the day order because in here, actually, I forgot to add it here. Now we are going to Monday to from Monday, Tuesday to Sunday, right? So on and so forth. These ones are just the heat map, getting the pivot data, right? And which one is the label will be the count here for this one. This one is the JVC bar, GC bar. Okay. Okay, guys. I think this is understandable. This was another way we can do. Okay, this one is and I'm adding here color blend, if you guys think. So this one is the friendly colors. You should always use it because you never know, some amount of the human population is color blind. and you don't want to just, your reports and presentation has to be accessible by everyone, right, in your company. So for example, and vendor IDs, we are looking for, seems really consistent with each vendors, but seems vendor's second one is a little bit higher than the first one. This is the other observation. And of course, when you are making visualization, just add the descriptive values in the each axis, right? This one is frequency, right? This one is the tip amount. We are just comparing the tip amount. It's a dollar sign, right? This is how can you present your report. Okay, so mean tips by the passenger count. So what we are trying to say here, if the whether passenger count is affecting our tip amount, right? And so if somebody, for example, I'm a driver and somebody told me, hey, if you just get to this, of course, this one is yeah, I sort the values here. Just basically, I'm grouping by the values by the passenger count, right? And then getting the tip amount and calculating the mean value and resetting the indexes and sorting the value by the tip amount. And I'm saying ascending false, otherwise it will just sort them like that. And for of course, zero rider. But if you have, for example, if you have 5 riders, that means your mean tip value is more. And seems if you have 2 riders as well, should prefer 1 rider. But usually multiple riders seems less tip, guys. Okay, so this is what we can observe when we give a tip to our drivers, right? Okay, so and just to make a visualization, mean tip values, as we can see. Okay, so yeah, as I said, 3, 4, and 6, and just lowering the mean tip value, and you can add that button and by visualization. I hope you guys understand Matplotlib and Seaborn, and we are just figure, and we are creating X. Here, Seaborn bar plot, which is these bars, and what we are giving him, we are giving our data as a mean tips by the passenger count, right? The passenger count is greater than 0 because I don't want to see the 0 values, right? And also, and for X values, X axis passenger count, and for Y axis the tip values here. Then I'm just adding that axis, setting the label, X label, Y label, set Y label here, average tip amount, right? This is Y label, Y axis and Y label, and X axis and X label, so on and so forth. Okay, this one is the PLT, the title. You can just change the font size and change the title name. Okay, this is another point. Okay, so this is another way, and let's just explore the revenue. One of the important things as a data analyst, you are just understand to what explodes. Of course, there are many ways, and this is not the exact data tips. You can just create a margin waterfall and also pricing waterfall. It's a different story as you can do, right? So what we are doing here, grouping by our data set by day, that means you are getting the each day on the lines, and with each day, you are summing up the total amount, coming to Monday and get the each Monday, make it 1, and sum up the all total amount. Well, this is how group by works. I just wanted to explain. I hope I'm explaining it clearly to you. And okay, so day order, I'm giving an order. It's just to really make sense to observation because we are really used to Monday, Tuesday, Wednesday, and total amount of day, right? So I'm re-indexing this data using the day order. That's why I created, and this is the total amount of the date. I'm just making the again the reset index. So now we have days and the total amount for each day. Now we can just compare that. Basically, looking at this table is you can understand that, but visualization is much more makes sense. What we can do, this kind of data, if you have numerical and categorical value, best way to visualize this is just creating a bar plot, okay, for each value you have. What I'm doing, creating another figure, 12 to 8, and Seaborn bar plot, give the data set, which is my data set, total amount of day, right? And for X axis, give the day, that will be days, Monday to Tuesday, and y-axis, that will be total amount, right? Then those ones are just setting the labels and also adding the line, right? Horizontal line in the axis, add a horizontal line where what would the total mean by the week? So I want to compare each of them by the week. What will again? We will have a horizontal line type of this. You can change it. You can even do it. Right, and you can change the color and so on and so forth. And you can give it a label too. Well, it's not a thing I think. Anyway, so as we can see, the revenue by day, Thursday, right, Friday, and Wednesday, as we can see, revenues are high, right? But Monday and Sunday, we have less revenue. Tuesday, Saturday, and these days we have more revenue. Okay, so let's so what I'm going to do. So we have revenues, and we understand which days we are making more revenues. Now I'm going to compare total amount and trip count by day. Okay, so which means how many trip we made and how much money we made. Right? How can I do? Group by day, total amount, sum, what we did, and then make it data frame again. Because after that, I will get a different calculation for the day, and then I'm going to merge them, right? Group by size, I already explained this one. It will give us a day and make it data frame. And what I'm doing here and just merging is these two, what we did before and previous visualization, just merge them using day on day, okay? And so what's happening, and I'm just creating day order and merge day and just categories day order true, and sort values by the day, and then I'm going to make a visualization. Okay, so what we have here we have total amount, for each day, $10,000, $20,000, $50,000, and the green values here and our trip counts, 3,000 trips, 3,400 trips. What we can observe here, for example, we have same revenue here, see, right? For Saturday and Sunday, I'm just gonna just explain it. So we have almost a similar revenue here, right? It's actually, yeah. So, but there is how much difference between, probably, there is maybe 100 trips difference, right? Less than 100 trips difference, but look at the trip count. See, so we are almost making 350 trips in Saturday, making this amount of revenue, right, around 50,000. But in Sunday, we are making close to this revenue, but almost less than 320 trips, right? This is what I'm to explain. This is what we give you, right? So this is the difference. For example, okay, you are making less money than this, but this one, right? But you are making with that amount of money doing less trip. That means there's something with these trips, right? Probably is I don't know actual reason, but I'm sure they will do. Okay, so this is how can you interpret, or other way, how can you visualize? And you can just make two subplots, right? And do it side by side. What I did here, I created a different bar plot for each of them, and just using one of them is the total amount, using some of them is the count, and also using the day as other. As you can see, trip amount, trip count, whichever is easier for you, or whichever easier for this data visualization. If you're creating a dashboard or just presenting the report, this is an empirical process, guys. You don't have to just create a perfect visualization. And if it's not because usually the users or executive, they don't know what's the story of in the data. You know that. But instead of creating a really good dashboard, but it's not answering the business problem, this is it. You spend a few weeks or 2 weeks just finding those data and creating that dashboard, and it's not answering the business problem. But by asking, keep asking, hey, would you prefer this visual or this visual? Is this answering your question? What you are looking for? And I have this is the story in the data set. What is your expectation? So on and so forth, right? It gives the same answer and depends on the population. For example, this one is much more sense to me interpretation, right? This one is the thing. Okay, but this one is they give the story, almost a trip count is really similar affecting the total amount. But as I said, and I mentioned here, there are some difference in the dates. Okay, guys, so then let's compare the trip distance. Another thing, I'm comparing the two different variables, trip distance and trip durations, okay? So here, I'm gonna go a little bit faster. Okay, so what we have in the data frame, trip distance in the x-axis and y-axis trip duration in the minutes. What we are observing here, let me just make it a little bit smaller, the screen. Okay, we have here and trip distance, right? Duration is higher, but distance are actually low. That means there is a problem here. Okay, trip distance is 40 minutes. I calculated here 14 minutes. That means 24 hours. These are problem. This bit visualization, we understand them. There was a trip took 24 hours. Look at the trip distance, less than 5 miles. This is a problem. There is a problem here. We need to understand. We will ask the business department, whoever is looking at it, and just understand. Otherwise, as we can see, trip distance, and if the distance increase and duration increases, right? Not really a high thing, but as far as I understand, with distance and duration is not really increasing dramatically. Probably is just you are picking up the very busy areas and you are just getting rid of the traffic, right? That might be a reason. Okay, let's just check that the trip durations are higher than the 800, and there are many. As you can see, how can we understand this? What is the problem here, right? After looking at the scatter plot, I read there are sometimes 20 hours. We should examine these issues, right? Okay, let's just, I want to compare the trip distance and the total amount and see how this works. And we are getting on our data set, and X values trip distance and total amounts. And these are I'm explaining the text values just to see better. And as you can see, distance increasing, trip distance increasing, and total amounts also increase. But as you can see, these areas, guys, and after increasing, that one is really not affecting. What would I do as a writer? As you can see, there are shorter writers, right? Short writes and distance short, but amount is high, right? I would prefer those writes, right? Okay, this is another observation we can get. Okay, so and comparing the trip duration and the total amount, what I am getting, again, this time is I'm getting total duration in the minutes and adding the total amount and the same visualization, guys. These are the title labels and setting the tips here and adding the grid. Okay, so trip durations, total amount here, durations here. Okay, so as you can see, guys, and if you have shorter trips, that means you are actually relatively making more money. When your trip duration increases, total amount of money is decreasing. I think they should find some kind of solution for that. Look at it, short distance, short durations, less than 15 minutes. And most of see, we are accumulating these ones here. Probably the trips mostly is 15 to 45 minutes. And shorter distance, and you are making more money. But as you can see, duration is increasing, total amount of increasing. Not in the same magnitude, but yeah. And also plot total revenue by month. And what we get, we were just grouping by the revenue and summing them, and we can just, okay, okay. So what we get is this data is there's no need to explain, guys. And month orders, right? Total amount, we are getting the month and summing up, okay? And then visualizing is data, total amount, month, what we did find here. And using this data set, get the month in the x-axis, get the total amount to y-axis, and give me a bar plot. Okay, these are the next rest is the giving the name of the labels. What we are seeing here, let me just a little bit go back to show better view. As we can see, summer ones here, July, August, and also September, we are seeing less revenue in those months. And maybe, for example, if I was a driver, I would just take a time off and just go to vacation in this month, right? And also February as well. There's a rest rides as well. Okay, so let's continue. So plot trip mean distance of the drop-off location, number of unique values. This is not really important actually, but as we can see, drop-off location, as you can see below, seems these values are not important for the drop-off location because it's an ID. Don't look at the magnitude of these values, higher or something. But as you can see here, and it seems it's just wherever you pick up the rider is just your trip distance. It seems it's just consistent, right? Doesn't matter where you're picking up. You're basically doing the same amount of the trip. And then, as I mentioned, I just make that visualization a little bit bigger here, drop-off locations, and also I made it in pickup of locations. I mentioned above, and I just make this that this means these are the busy traffic areas. Okay, this one what we shows here, and this is consistent in the same areas. That means we are picking up the people in the same areas mostly and dropping them those areas after picking up somewhere else. Okay, these are probably maybe Manhattan or the busy places in the New York. Okay, guys. I hope you guys understand everything. It's getting a little bit longer. That's why I just have to pass some parts on speed up to some process. But if you guys have any question and didn't understand anything else, please feel free to ask. As I said, in data analysis, after you get used to data and you will ask the more question, what is your aim here? I want to increase maybe more trips. I want to increase revenue. I want to increase gross margin. Depends on your data set and your story. You will have asked same question, Googling and asking, and like large language model GPT is really helpful because it will speed up your process. It's not going to answer every question, but you can get really good help from it. Hope to see you in the next videos. Thank you so much for watching my videos, and yes.